Welcome. In this video lecture, I am going to talk about some simple forecasting methods using R. Okay. As well as we will also discuss about how we can calculate the in-sample forecast error, as well as how we can calculate the out-sample forecast errors. And then we will going to compare those methods, which method is suitable for the particular data set. Okay, the first method we are going to discuss is the mean method, or you can say the average method. That is simply the future value is going to be the average of the historical data. That would be the mean method. The second method we are going to discuss is the naive approach, or you can say the naive method. So in this method, we are saying the future value is going to be equal to the last observed value, or the last actual value of the data set. Okay, so whereas in a seasonal naive method, we are saying that whatever the last season particular value is, those values are going to be equal to the future values. Like if I am saying that we are calculating the monthly basis forecasting values, and we are going to apply the seasonal live method. That means in the last 12 months, okay, whatever those values are, that is going to be the future years, whole years, the forecasted value according to the seasonal knife method. And the third one, so over here basically y is basically indicating the yt is indicating the original values, h is the forecast horizon, that is the basically the seasonal period we are calculating m. Okay, whereas k is going to be calculated like this, that is basically a smaller integer number. Okay, whereas in a drift method, we are saying that the drift method, the forecasted value be equal to the last value plus change over time. Okay, so that is basically this is the change we are calculating, or you can say drifting, which we are calculating, right? So let's apply these methods using R, and then we will also calculate the forecast errors as well. So for that, I am first of all needed the package of R that is called as the forecast package. Okay, so let me increase the size of this one, the code. Okay, so this is basically, first of all, I'm going to call the library that is the forecast, as well as I'm going to call the package called as the next package I am needed, that is TSUTILS. Okay, so these two libraries, first of all, we need to install and then call. So how we can call the libraries, that is with the help of these libraries. And then basically I am interested to forecast monthly time series data. Okay, so let me show you this data set, which is basically ts2. Okay, so these are the data set. Okay, that is basically the monthly data. Okay, as well as I have also created the out of sample. So these are basically the out of samples, or you can say testing data. This is basically the training data. Okay, so with the help of this training data, we can calculate the in-sample forecast error, and with the help of out-of-sample forecast error, or you can say with the help of testing data, we can calculate the out-of-sample forecast error. So first of all, I am going to read this text file. Okay, so how we can read it, that is with the help of scan function, and then ts2.text. Okay, because this text file is in that folder where I have created this project. Okay, so that's why I am just writing down scan and then the name of the file. If that file is not available in that particular folder, that then you need to give the whole path of that particular file. Okay, then I'm saying that the start of 2011 one, which means I'm saying that this is the monthly data. So that's why I'm saying the data set of those values are starting from year 2001. So this one is mean that is the starting month is the January. Okay, and the frequency is 12, which is basically indicating the monthly data. If it was quarterly data, we can write down 4. Okay, if it is the annually data, we can write down frequency is equal to 1. Okay, so that means first of all, with the help of this ts, that we are converting this data set into the time series. Okay, and then I am storing into ts2. Then I am going to plot this data set. Okay, as you can see that on x-axis we have the time, on y-axis we have the actual data set, which is basically the you can say monthly data set. Now I am going to read the second text file, which is basically the you can say the test data, that is again a monthly data, and it is starting from 2016 for January. Okay, so now I am reading this one file, which is basically in ts 2 dot test uh, variable. Okay, now I'm saying that this ts2 is going to be equal to y. That is basically we are storing this time series data set into a variable called y, whereas this test data set I'm going to store into y2, y dot test. Okay, then, in order to find out the forecast horizon, I am calculating the length of, or you can say the number of observation in this particular variable. So how we can do that? That is length y dot test. So that is equal to h. So which means, so the next 12 months are going to be our forecast horizon. Okay. So that is basically the number of values in the test data set. Okay, whereas if you want to see the original data set, which is y, okay, if I'm writing down, that is starting from 2011 January to December 2016, right? Whereas y dot test contains the test data values, right? Now I'm going to apply the first method, which is a mean method. How we can do that? That is with the help of mean function. So that is mean f, that is a mean forecast value. And then I am mentioning the original values. So the original values are stored in a y. Then I am mentioning the forecast horizon. I am saying that I want the forecasted value of the next 12 months because h is equal to 12. So if I run this one and then I am calling f dot mean, you can see that it is showing me the forecasted value from 2016, January 2016 to December 2016. So these are the forecasted values. These are the prediction interval at 80% confidence interval as well as the 95% prediction intervals. Okay. So if I want to see only the fitted value against January 2011 to December 2015, that is basically the in sample forecasted value. So I can use f dot mean dollar sign fitted value. So you can write down f dot mean dollar sign. So here we have the what kind of method we are applying, what are the levels. Okay, levels means that is the confidence levels. Okay, then over here you can find out the fitted value. So if I run this particular command, you will get the fitted value, or you can say the forecasted value against the uh, training data set. Okay, okay, so so these are going to be used when we are finding the forecast error within a sample. So now let me plot this forecasted value, which is f dot mean. If I am plotting this one, you can see this is basically the original data set. This is basically indicating the forecasted value, this dark blue line with the help of mean method, and this dark gray color is indicating 80% prediction interval. This light is 95% prediction interval. Okay, so let me call the future only the future. If you do not want to plot these, you can say the prediction intervals. You want to only access these forecasted values. So for that, you can write down the function f, write down the command f dot p dollar sign and then mean. Okay, let me show you dollar, and then over here we have a mean. If I run this one, you will see that from January 2016 to December 2016, because our forecast horizon was 12. Now, what I am going to do is I'm converting into the time series of these mean values, these one, this one, as well as I am saying the starting point is equal to the f dot test, which means the starting point of this data set is January 2016, and the frequency is going to equal to f dot test, and how much frequency, that is 12 months. So first of all, I am converting into this into the time series. Then I am going to plot, which is with the help of TS time series plot. This is the original values that is going to be shown to me. These are the test values. Okay, this is the forecasted value. So the original values is going to be shown with the blue color. Test value is also going to be shown the blue color, whereas the fitted value, or you can say the forecasted value, basically are going to be shown in the red color. So if I am going to run this command, so you can see that these are the actual data set. These are basically the forecasted values. So this one is basically the you can say with the help of mean values. Okay, not sorry, this is not the forecasted value. Basically, this is the test values. This is basically the forecasted graph. Okay, now the same procedure we can use to find out the naive forecasting method. So there are a number of ways to find out the naive forecast method in R. The first approach which I am going to use is I am going to use the function of replication of the tail, the original values of the last original value, okay, up to forecast horizon 12. So if I run this particular command, okay, and you can see that it is showing me the last value. So if I am saying this one, this is 3088. So this last number is going to be repeated 12 times, okay, as you can see, because our forecast horizon was 12. So there is another way that we can use. So we have the naive function, okay, and I am saying original value. This is I am showing that the forecast horizon is equal to h, which is 12. So let me run this command. We are going to get again the original forecasted value as well as the 80% confidence with the help of this particular function. So in order to get the fitted value, so I can run this again particular command in order to get the within a sample forecasted values. Okay, so you can also get the naive forecast value with the help of the function RWF. Okay, that is also giving us the same forecasted values as we are getting previously. Okay, that is this one. Okay, so similarly, I'm doing the same thing which I have done with the mean method. I'm going to convert the forecasted value into the time series. So this is basically the mean values with the help of the naive. This is basically, these are basically the forecasted values. Okay, so this is basically the future forecasted value, right? So the start time is, I am saying that the y dot test and the frequency is equal to y dot test number of values. Okay, if I run this, and again if I am going to plot this one, so this is the original data set, this is the test data set, and this is the forecasted value with the help of naive approach. So now we are going to apply on a seasonal live method. Again, in order to find out the seasonal live method, we can use either the manual way, which is basically using the built-in R function, that is repeat the tail values of y, okay, and then we are mentioning comma how many time it is going to be repeat, that the frequency of the y. So that is the number of values of the y, okay, and then how many time it is going to be, that is basically we are indicating the seasonal component, okay, divided by the forecast horizon. Okay, so this is going to be equal to the 12 future forecasted values, right? Now, if you want to use the proper seasonal naive method, you can use this particular function s naive. This is the original value, this is the forecast horizon. So we can do this way as well. So again, in order to find out the within a sample forecasted value, we can use dollar $fitted. Again, I am converting the future forecasted values as well as the time and the frequency in order to convert into the time series, and then I am plotting it. So again, this is the original data set, this is a test data set, this is a naive forecast method. Okay, so as we have seen from different three graphs, so this is the mean method, this was the naive method forecasted value, this is the seasonal naive method. It looked like among these season naive method is the better one. So let me find the forecasted value with the drift method as well. So in a drift method, we can use the function RWF, that is random walk forecasted value. So we are saying that a y, okay, and drift is equal to true. Okay, we have to mention this one. Okay, then we can run this one in order to find out the in sample dollar fitted future, converting the future values in the time series, and then we are plotting. This is the drift method. Now, in order to check the accuracy, mean which method is better within a sample or in a out of sample. So, in order to find out the forecast accuracy of the within a sample, so how we can do that? We can use the function accuracy from the forecast package. F dot mean, that is the fitted value, which is the training data sets of fitted value, or you can say the corresponding to the training data set. This is the actual training data set, and this is I am using in a mean variable. I am calculating this one. Okay, so let me do this one. Why it is I'm getting error? This is the mean fitted value. Okay, this one. Let me this one. Okay, and then I am going to again run this particular command. Okay, now we are getting this one fitted value. Okay, now I have to do this one again. This is Y fitted values. This is again S knife fitted value. Okay, again we have to, let me run this one again. F knife, this one. Now we are getting fitted values. This one. So again, I'm running this one. Okay, this one. Now we are going to calculate the accuracies of all three methods with the help of mean, knife, seasonal knife, as well as drift. And then with the help of this R bind, that is a row bind function, I am saying that I am going to combine row wise these three variables. Okay, and I'm storing into f dot all, and then I'm giving the name of those rows. Okay, so basically to the mean, I'm saying that the give the name of the mean, then knife, then seasonal knife, and drift. Okay, so basically giving the row names, and then I'm calling it. As you can see that with the help of those accuracies against the mean method, if I'm using root mean square method, the best method is basically the seasonal knife method. If I want to use the mean absolute error method, then the best method is the drift method. If I am going to take the decision with respect to mean absolute percentage error, then the best method again is a seasonal knife method. That was a within a sample forecast error. That is normally is not a good approach. So the better decision is that we should take out of sample, which means we are going to calculate using the test data. Okay, so for that, we are using the forecasted value and the actual test data. Okay, that is again going to, I'm using the same command. Now, with the help of these out of sample, we can say that if I'm using root mean square error, the best method is a seasonal knife. If I'm using mean absolute percentage method, the best one is the drift method. Okay, similarly, if I'm using simple mean percentage error, again drift method. So against mean absolute error, the best method is the drift method. So depending upon what kind of measure of accuracy you are using, you can pick. So we can see that with the help of mean absolute percentage error, with the help of mean absolute error, as well as with the help of mean percentage error, the drift method is giving us the better forecast compared to other. I hope you got the idea how what are the simple forecasting methods are which we can use to predict the especially the fast moving data, such kind of the data. Okay, and how we can find out the within a sample forecast error as well as the out of sample forecast error in order to select the best forecasting method. So thank you so much. See you in the next video.